Amazon was celebrating its first birthday and they only sold books. We were in a small hotel on the bottom floor with some of our most close users, and now we're in a giant convention center like this. So thank you all for being here. 25 years ago, I was just getting out of a graduate program where I was doing cutting-edge research on something now which seems mundane. We were building the world's first video conferencing system that used the internet rather than ISDN. So it has been a long, fun journey over 25 years, and we are so excited to have you with us today. My name is Charles Schroeder. I am a business and technology fellow with National Instruments, and I have been here for that entire 25 years, working mostly in research and development, but also in marketing, some in the business side. And now I am back in R&D, where my role is to work on the disruptive technologies that hopefully you will all be writing about in 2023. So maybe I will see you back then at that point in time. But again, thank you and welcome to NI Week, the leading conference for test and measurement professionals. We are very excited to have you here. It is NI's mission, not just our mission, but our passion as well, to equip scientists and engineers with systems that accelerate their productivity, their innovation, and their discovery. And we take this very, very seriously. There are a bunch of challenges in our time. There are societal challenges, there are economic challenges, there are environmental challenges, and we are firm believers that the world will see solutions to those challenges that come out of engineers. And it's why we are so intent on ensuring that they have the systems that they need to be productive, and innovative, and efficient in their jobs to get their work done. The problem is that they've got some challenges, some real challenges that as you meet them this week and talk to them this week, they will echo these things. The devices are more complex and more converged than they have ever been. And they need to get them to market faster. And oh yeah, by the way, they're dealing with smaller development teams while they're doing it. And they are really struggling to keep up, and we know that because they tell us every single day. Again, this is why we are so intent on helping them. I'll give you an example of how that plays out. 10 years ago, if you wanted to test the brakes of an automobile, it was pretty simple. It's a stimulus response type of test. If you push on the brake should engage the wheel, pass, fail. We understand that. But think about today's cars. With the safety systems in those vehicles, yes, if you push on the brake pedal, you definitely still want the car to stop. But that car also has radar sensors, potentially LiDAR sensors, ultrasound cameras that are scanning the environment, looking if a child is going to run in front of the vehicle, or if there's a car in front of you. And now a machine learning or an artificial intelligence algorithm and an advanced processor in that car also has to be able to push the brake. How do you ensure that happens? It is orders of magnitude a more complex problem than brake testing was just 10 years ago. And that's just one example. We see that across industries, where this convergence of technology, the internet, the connectivity, the sophistication, the algorithms are making what was simple to test 10, 15 years ago much more complex today. This week, you're going to see a bunch of new products from National Instruments that we are very excited about, and I will give you a preview of 5 of them in a minute. But you're also going to hear the customer stories behind them and why we think they're so important. You're going to hear from companies like Bosch that are standardizing on the NI platform as a way to transform the way they do tests across their entire company. You're going to hear exciting applications like Virgin Orbit, who is trying to get from the design of a revolutionary space vehicle launch technology to the testing and the certification and the deployment of that faster than is normally possible. And you're going to hear from companies like Vallejo, who have used the NI platform to reduce the cost of deploying new test solutions by more than 50%. That is when we talk about engineering efficiency, if you can reduce the cost and the time to market by 50%, that is a really big deal to these companies. Now the key, how do we do that? What do we offer them? It really comes down to our software-defined platform of capabilities. It emphasizes 2 things. It emphasizes first the flexibility, so that our customers can get exactly what they need for their unique testing challenges, and it's layered with software that helps them get to market much faster than would be normally done. That flexibility comes from a couple different elements. First of all, it comes from modular I/O, meaning they can pick each hardware component they need. If they're testing a brake system, they can pick a radar sensor, they can pick an ultrasound sensor, they can pick maybe a power supply. They can put together exactly what they want. And that's really, really key, because if you look at solutions from some of our competitors, they offer turnkey solutions that just simply do not offer that level of flexibility. Now, our customers are deploying singles, tens, even hundreds of systems, and they're doing it across the world, and now they're faced with a new and really complex challenge. How do I manage all of those distributed systems and the data that goes on them? So let me give you an example. Let's say you're a semiconductor company that is doing design in California, but you're doing manufacturing in Asia. You bought your design systems 1 year, and then maybe a year later you purchased the manufacturing systems. They're purchased at different times. They may have come with different versions of software. They're deployed in different locations, and when they're running the tests, the data is stored on their local hard drives. So if you're trying to run that organization and really drive efficiency, how do you know when a module in Asia needs to be calibrated? How do you get all the data from your design systems and your test systems in one place so that you can reason on them and see if your test process is drifting away from your design process? It's been really, really hard. And our customers were begging us for a solution, and so last year in 2018, we released a brand new product called System Link, which is now the choice for managing distributed test systems and the data on them. And I'm going to show you some really new capabilities of System Link now, but it has become the backbone of the infrastructure for large deployments of our test and measurement applications. Really critical capability. You're going to see this week how our customers take that core platform of capabilities that I just talked about and use it across a diverse set of industries with a diverse set of challenges and how they make use of that. And you're going to hear from some of our 35,000 unique customers that are deriving value from that platform today. I strongly encourage you to talk to all of them, get their stories, find out, and they will tell you the same story that I just told you. It's really exciting this week. So now let's get to the real meat of the presentation. I think is the new products, the new announcements, and show you some of the new capabilities that our customers are really excited about. So we talk about engineers and scientists and making them more productive. All engineers and scientists one day started as students. And so it's probably no surprise that our journey would start there. I remember when I was in school, theory was a big deal at the time. And so about 80 to 85% of the studies that I took were about theory, with some labs that sought to apply it. But as we talk to companies today, again, they're dealing with much more complex problems, much faster time to market. A student that has never really designed a real system is not as valuable anymore as it was when I was coming out of school. Companies are not so patient to spend a year training their engineers. They want students that have a better balance of practice and theory in real-world situations. And so this year we are very excited to announce the third generation of our Elvis product, or the Engineering Lab Virtual Instrumentation System, that helps students learn that practical experience and the theory at the same time and puts it into one place. There are two key features that are really important about this version of Elvis. The first one is the software experience. It is a cloud-enabled, zero install, you get it from anywhere, your mobile phone, your tablet, your laptop experience. So if a student's in the lab, they can use the Elvis 3. If a student is back in their dorm room, they can still access that software, and it's on the device that they're all carrying in their pocket. So you have accessibility anytime, everywhere. Super important. The second thing about it is we put a lot more emphasis on the project-based learning. It's not just individual labs. They can actually take a design and go through all of the different stages. I'll give you an example. Let's say you're designing an audio system. You can learn some lessons about the analog electronics that it takes to turn sound waves into electrical signals. You can learn about the digitization technology that takes the analog signals and converts them into bits that a processor can reason over. You can then have a digital signal processing class that takes that data and adds cool sound effects and reverberation, something the students would find engaging and interesting. And then the same would be true. You take that modified signal, convert it back to analog, convert it back to sound waves, and now over the course of a semester, they can experiment with analog microcircuits, experiment with digitization technology, experiment with digital signal processing. And at the end of the day, they have built what could be a real-world product, tying all of that theory and practice together. We're super excited about our partnership with Texas Instruments. If you've been to NI Week in the past, you know we have a deep relationship with TI. They have always been a supplier to us and a core supporter of our academic efforts. But when they saw Elvis 3 and the real practical learning that the students would get, they immediately saw an opportunity that if it was in the universities that they hire from, it would immediately benefit them because the students would be graduating with exactly the knowledge they need. So TI is not just a supplier or a partner now. They've actually designed hardware that goes on top of the Elvis 3 and a full curriculum that goes with it that instructs students in what they need them to know in microelectronics and microprocessor design. Fascinating, and we're really excited to have them as a partner. Switching to LabVIEW. LabVIEW is our flagship software and system design tool. As you know, it's been over 30 years we've had LabVIEW, and it is the leading test and measurement software in the industry. As a reminder, there are really two versions of LabVIEW. LabVIEW the year after it, 2019, which is that core technology that is the #1 programming language for test and measurement everywhere in the world. And then a couple of years ago, we announced a ground-up next-generation version of LabVIEW that is still growing in its capabilities, and we call that LabVIEW NXG. So in LabVIEW 2019, we've got two core features. The first is something called packaging technology. What that means is, when we released NXG, the new version of LabVIEW, it included some software technology in it that allowed our customers to better manage and deploy software to their distributed systems. And customers really love that feature. And so we've added that to LabVIEW 2019 as well, so that customers across the world, no matter what version of LabVIEW, can take advantage of it. And that's package technology. The second one is some new data collection data types. And these are the first data types we have introduced in LabVIEW in probably close to 20 years since arrays and clusters. So this is a really big deal. And the reason why these two are so important is that our customers are dealing with more and more data than they have ever had to reason about in the past. And the two types, maps and sets, help engineers work in map and set theory to manage that data, to process that data, and extract value from that data. Okay? With NXG, we've got some new capabilities, better integration with MATLAB software from the MathWorks. And I've got a whole slide on that, so I'll tell you more about that in a minute. But we also have some really cool capabilities that are called responsive user interfaces. And by responsive, I don't just mean fast. I mean that when you design a user interface in LabVIEW, that interface will look beautiful, whether it's on a mobile phone, whether it's on a tablet, or whether it's on a PC. And so that's really nice technology for customers to deploy beautiful user interfaces regardless of the platform. So I wanted to say a couple words about the MathWorks. In the past, we've been both very successful companies, serving very complementary sets of customers at different stages in their workflow. But I mentioned earlier how passionate we are about helping engineers and scientists be more efficient. There's always an opportunity for heartache if you have to move from one vendor's tools to another vendor's tools. They don't work exactly the same way, you fight with data and so forth. That's not efficient. So they're the leader in their space, we're the leader in our space. It is absolutely natural that we would work together to remove all of those barriers so that our joint customers can get their quality products to market more quickly. That's why we're very excited about our new cooperation with MathWorks. All right, earlier I mentioned SystemLink, this backbone, the solution for managing test systems and their data. We are really, really excited about this product. You are going to hear a lot about SystemLink this week. But there's a couple features in SystemLink that I want to talk a little bit more about that is in the latest version. The first one is called an asset module. And when we say asset in these terms, we're talking about those test and measurement systems that our customers have deployed across the globe. But let's say you've got test systems across the globe. Wouldn't it be nice to know that one of your assets was only being used 20 or 30% of the time? I could operate my efficiency if I could see across my entire network of devices the utilization of all of those assets. And that's one of the functions that that asset module allows you to do, so that you get the most out of every capital equipment dollar that you spend. The second one is a module that allows us to gain insight on the tests that are being run. So now imagine I have those test systems deployed in Asia. They're manufacturing modules at a very high volume. Imagine if I were in California and could actually see my tests running in Asia and which tests were passing and which tests were failing. Is my yield exactly what I expected? Or is it trending up or trending down? It might indicate a potential problem for this company. This allows our customers to see what's happening with those remote tests so that they can effectively manage their systems. And the last one is a data finder capability. So now I've got my test systems, they're deployed across the planet, and there's data residing on their hard drives. But let's say I want to investigate why one test isn't doing as well as I expect. How do I find all that data for all those test systems deployed all across the world? That's what this data finder module will allow our customers to do, is regardless of where it is, they can do searches, it will scan that capability, locate that data for them, bring it together, and now they can begin to reason about it and turn those insights they get from that data into a positive business result for them. Again, very excited about the System Link capability, and so is our alliance partner Soliton, the Indian company. Fantastic engineers, and they're working exactly on that problem that I just mentioned with leading semiconductor companies, how to find, how to collect, how to analyze, and how to report on the data that's distributed across the test systems. And because System Link is an open software platform, not a closed platform, they can add customer-specific business logic into each deployment that they do, which translates directly into solving the customer's immediate business challenges. All right, we're going to switch from monitoring assets that are test instruments to an industrial IoT application of monitoring asset. When we say asset in this context, we're talking about large rotating machinery, power plants, giant machines and motors, that type of capability. We have been doing asset management for a number of years with our Compact Rio product lines and with a software called Insight CM that helps our customers do predictive maintenance, meaning see literally inside the machines and understand if a new source of vibration might indicate that a ball bearing is about to go out. And so they've been doing that with our Compact Rio and our Insight CM software again for many years, and our customers love the capability. Really, it has helped remove the need for an engineer to walk around with a clipboard and to drive from factory to factory and manually test these things. But now in one location, they can see all those assets monitored, they can do predictive maintenance, their uptime is better, they really love the capability, but they've given one piece of feedback. We love it so much, we would love to put it on every piece of equipment. Right now, at that price and performance point, it's the perfect solution for our highest end, but we have a lot of lower cost pieces of equipment we would like to monitor as well. And so this year at NI Week, we're releasing 2 new hardware products for asset health managing that work with that Insight CM software. And to understand how to get the cost down, there's one thing we need to understand is where does the cost come from? It comes from 2 areas. Actually, half the cost of deploying a solution like this is the cabling and the infrastructure it takes to get power and networking capability to all of those assets. And then the second half is capital equipment cost. So these devices are battery powered and wireless. That immediately cuts 50% of that cost out. And then we have optimized them for cost of capital as well. So one of those devices is literally this small. It costs hundreds of dollars, and you can walk up and you can glue it to the side of a machine, and then you are instantly taking health data on that machine. This is an amazing new capability that complements the Insight CM platform. All right, and while we are on wireless, let me tell you a customer story. So actually, LG&E is exactly the story that I just told you. They have 5 different power facilities, and they are currently monitoring 55 assets at those 5 facilities with Insight CM and Compact Rio, and they are one of those customers that loves that capability. And they came to us a year ago and said, hey, we have several thousand more assets that we would like to monitor if we can hit a certain price point. And so we have been working with them. They literally have 2 engineers that are responsible for all of those several thousand plus 55 assets, and they literally have to drive on some schedule to each of those power plants with a clipboard and a remote device and make those measurements. That's the history. But now with both the Compact Rio, working with these new wireless devices, they can instrument all of that, and from a mobile phone or from their laptop back at their headquarters, they can see and understand the health of every system that they have deployed. It's really exciting technology. All right, sticking with wireless. 5G. So 5G is an area near and dear to my heart. That's what I have spent the bulk of my last 10 years working on. And during that 10 years, I've gotten to see a lot of changes in the 5G landscape. Actually, and I started working on 5G about that time, nearly a decade ago. For almost 10 years, we have been working on 5G. In those first 10 years, we were helping scientists and engineers at leading academic and commercial research labs take seeds of ideas on what 5G might be, to prototype those ideas, to prove them and to perfect them, leading up to the 5G standard. And we have been very excited about the set of announcements we've made enabling those researchers to prototype what has become 5G. But now the standard is finalized. It's released, and it's now time to make 5G a reality and deploy that. And that means we need test assets now to complement those prototyping assets. Last year in 2018, we were the first test and measurement company to release testing capabilities, hardware and software, for the less than 6 gigahertz portion of the 5G devices. Those are the same frequency bands that were used for 4G and 3G. So it's natural that those frequencies would be the first to release. And again, we were excited to be the first company to release test and measurement ability for sub-6 gig 5G. But now we're getting into the millimeter wave frequencies, brand new frequencies that have been the domain of military and aerospace or satellite communications in the past. And we know that those are very expensive systems in reasonably low volume. So we need some help in terms of getting this technology down in cost and size to where it can deploy 5G in mass volume. And that's where we are super excited to announce the new first millimeter wave VST, or vector signal transceiver. We started from the ground up thinking about the unique testing challenges of 5G, and we have designed a system that is optimized for the cost-effective test of the needs of this particular standard. It is absolutely lower cost by far, it is much faster, it is much smaller, and it is the level of integration that engineers and scientists need for moving 5G out of the lab and into high-volume production. It is absolutely a necessary item in the vital to the commercial success of 5G. If we don't get the cost of the test systems down, we won't all get to have 5G in our pocket, and this product is a very important step. Over the next couple of days, you're going to hear from the wireless CEO of Jabil about the importance of this type of technology in driving the commercialization of 5G, and about some collaboration between Jabil and National Instruments. The product is so important to us, you're actually going to see 2 days worth of keynote demos that highlight different technology angles and different customer stories around the importance of this technology. I know that will be very, very exciting for everyone. While I've highlighted 5 products you'll see this week, there are many, many more. People from NI will be around you to help answer your questions, provide you information. Let us know. There are many more exciting capabilities. We just couldn't get them all today. And behind them are a set of customer stories as well. After each keynote, when the customers are on stage, you'll have the opportunity to go take pictures, meet them, ask questions. I highly encourage you to find out their stories, because they will tell you, not just NI tell you, they will tell you why these technologies are so important to their success. And we really are, as a company, we are on a mission. And it is our passion to equip those scientists and engineers with the systems they need to accelerate their productivity, innovation, discovery. It is more than a mission statement. It is what we are all about. And I really want to thank you all for coming, and I hope you have a wonderful night. With that, we'll open it up for question and answer. We'll get you a microphone so everyone can hear.
Hello. Yeah, hi. I'm Prem Shanmugam from Frost & Sullivan. A couple of questions. One is to do with the wireless monitoring hardware. What kind of wireless standard does it use, and how earlier I used to have WSN wireless sensor network. How was it better or replaceable?
Yeah, it's a good question. So we don't necessarily talk about it, but I will tell you it is a Bluetooth 5 version of the standard that has been optimized for distance and interoperability and tested in rugged factory situations where there is a lot of EM noise and radiation.
Just one more on the millimeter wave. Is it going to be on the PXI form factor still?
Yes, great question. So the millimeter wave VST is actually made of a number of different modules. And it's designed in a modular way because 5G millimeter wave turns out isn't just one thing. So if you'll allow me to get a little bit techie for you for a minute. If you look at the set of chips and circuits that make up a 5G system, there are processing steps that happen at baseband, which is low frequency. It's the frequency, it contains the raw data itself. But because the frequencies of millimeter wave are so high, it generally gets upconverted in two stages. The baseband interface gets upconverted to an intermediate frequency. This in case can range from 2 gigahertz to 20 gigahertz. And then it goes from the intermediate frequency up to the millimeter wave band of 5G. We've designed the millimeter wave VST to mimic that signal chain that our customers have. So there's a baseband module, and we convert baseband to IF. And both the baseband and the IF modules are inside the PXI chassis where they can synchronize, be timed with, and work with all of the other instruments from National Instruments. Millimeter wave's a little bit more finicky than the sub-6 gigahertz band. So you want the test equipment to be as close to the device under test as possible. So that last stage that converts the IF to millimeter wave signals is in a separate module that we cable out to, and you can put it right at that device under test to make an optimized set of millimeter wave 5G measurements.
So on that, what's the bandwidth and EM components?
So, of course, it would you have to ask the detailed RF question. On the bandwidth supports up to a gigahertz. It's using the same second generation VST as its baseband engine that powers that technology. EBM is a set of curves, and I will refer you to the data sheet of the product for the details.
Microelectronics. So I have a question about the new system link. That it seems that the asset monitoring module, you can monitor all the utilization of your testing asset. So is that possible for your customer or the SI to collect those data and integrate those information into their own MES or shop floor, because this is how the manufacturing the production line that works.
Yeah, so with the System Link product, the companies can they can run it on their own servers inside their enterprise, or they can run it in their own cloud. It's up to the customer to decide where to deploy it. National Instruments doesn't see any of their utilization. So they deploy exactly the capabilities needed on their network or in their cloud, and it monitors their assets for them, and then because it's open and works with LabVIEW and the other languages and testing and so forth, they control how that data gets used. Yeah. But it is definitely, it's a set of tools and a collection of tools that they use to deploy the capability that they want. And I never see is their data or utilization.
I think that's okay, but for the user, they may want to further integrate with those with their own MES manufacturing execution system.
Yes.
Yeah. So is that possible for the customer when they want to do that?
So there are a set of open APIs. I think it would depend on the particular system, but it is designed to be extensible and open and to connect to third-party tools. So depending on what their system is, I'm sure there are different interfaces, whether it's at the data level or an API level that can connect the two.
Okay. 5G is harder than 4G or?
I'm sorry, one second.
5G is harder than technology or 4G?
5G is harder than 4G?
5G is higher than 4G?
Harder.
Harder?
Yeah.
Oh, yes. Yes, 5G is significantly harder than 4G. I would say it is probably the single biggest step in technology since the invention of cellular technology itself. Really there's two answers in there. There are a set of sub-6 gigahertz technologies that feel more evolutionary. So when we're operating in the same frequency bands that 4G, 3G, 2G, and 1G did, the world is pretty well understood. We've already hit economies of scale. We've already hit yields that are high, and we understand the physics of that very, very well. None of that is true of the millimeter wave bands. The millimeter wave bands are far more revolutionary than evolutionary. But that's where all of the new bandwidth and performance is. And so if we want to move and take advantage of all of that additional spectrum, we have to cross those challenges. In the keynote on Wednesday morning, I would encourage you to go there, because the CTO of Jabil and I will be talking about 3 of the technologies that make it so hard. Millimeter wave and just the physics of millimeter wave, and taking that from a low volume satellite kind of standard to a high volume consumer electronic standard has a lot of challenges. You're going to see some good stories about the millimeter wave VST and how that works. There are also 2 other technologies in millimeter wave 5G that are very, very hard and new. One is called massive MIMO, and the other is called beamforming. And I'll get a little bit techie again, but millimeter wave signals, as they propagate at those frequencies, attenuate faster. It's harder to get range than it is for the lower frequency signals. That's why AM and FM radio can go forever, but your cell phone barely makes it to the tower, and as you get to millimeter wave, the problem is even worse. So rather than a single antenna sending information in all directions like our phones do today, a millimeter wave system may have 16, 24, 64 antennas, because it takes that many antennas to focus and actually physically steer a beam of energy between the base station and the mobile device. And that technology is still being proven in the lab and is significantly harder than what we've seen in 4G, 3G, 2G, and 1G. So stay tuned for Wednesday morning. We're going to show some videos, we're going to explain how that technology works, and we're going to show some really kind of amazingly cool, blow your mind demos about what that energy looks like in the air.
For 5G, that is non-standalone and standalone, and non-standalone is what is being implemented now, right? So, NICE test, have you also ventured into the standalone 5G testing, or what stage?
Okay, so to back up on the question a little bit, the question was about standalone versus non-standalone implementations. If you're not familiar with 5G, just a quick, short introduction. Non-standalone is first, and what that really means is you still set up your phone call using LTE-like communications. And then once the phone call is set up, connection is set up, I guess to be more exact, if you need more bandwidth, they can turn on a millimeter wave pipe to get data back and forth. But the call is still managed in a 4G world. Okay? When you get to standalone, that means you can completely set up, connect, and manage the entire call over millimeter wave. The initial implementations are non-standalone, and our customers, mainly in the labs today, are working on a non-standalone implementation. But we are part of the standards bodies, we are working with lead companies, and as the standalone capabilities emerge and get more concrete, you absolutely bet we will be there. Those are both critical applications for national instruments. All right, I will be happy to stick around for 5 or 10 more minutes if any of you would like to chat or maybe ask a question in a less public way. I'll be happy to answer them. Again, thank you so much for coming. We sure appreciate the time out of your busy schedule to be here with us.